Let's try example 2. A student is skateboarding down the sidewalk and travels at a constant velocity of 2.5 meters per second. How long will it take him to travel 1 kilometer? Well, there's some obvious givens here. 2.5 meters per second is some sort of velocity. 1 kilometer is a distance traveled, right? So I can call that a final position. So let me go ahead and list these. Velocity is 2.5 meters per second. The final position is 1 kilometer. And you know what? I think that's going to trip me up because I've got kilometers here, but then I've got meters per second here. And it's just going to help me to be consistent. So I'm going to go ahead and convert this. 1 kilometer, kilo means 1,000. So kilometer is 1,000 meters. Okay, I'm going to avoid that trap. And then, oh man, there's a hidden given in this one. The hidden given, if I think carefully, is in the idea of a constant velocity. Well, if you're moving at a constant velocity, you're not speeding up, you're not slowing down, you're not even turning if it's a constant velocity. So by definition, that means that your acceleration is 0. So I can put that in my givens. And finally, if the velocity is constant, it means that the initial velocity and the final velocity are the same. So I can say that the initial velocity is 2.5 meters per second. And I can say that the final velocity is 2.5 meters per second, right? That's what constant velocity means. So I pulled out a ton of information, many of it hidden in the description of the situation. And now I just have one unknown, and it says, right, how long? So I'm being asked to find time. All right, if I look at my unknowns and I look at my givens and I say which equation groups all of this information in one and allows me to find the time, I'm going to try equation 1. Okay, that's the final position is equal to 1/2 a t squared plus v initial times t plus the initial position, right? The final position is 1,000 meters. The acceleration is 0. And the time, I don't know, but it's all going to go away, right? Because 0 times anything is 0. Plus the initial velocity of 2.5 meters per second times t, it's my unknown, plus the initial position. If I'm not given some sort of initial position, I can just say that the initial position is 0. So that's fine too, okay? All right, so this is going to simplify to just 1,000 meters is equal to 2.5 meters per second times t. That's it. Dividing both sides by 2.5 meters per second, because I'm going to try to isolate t and get it all by itself. So these are going to go away. And I'm going to get t is equal to 1,000 meters divided by 2.5 meters per second. So 1,000 divided by 2.5 is 400. And then what is meters divided by meters per second? Well, meters divided by meters per second means that meters are going to go away. And I'm going to get 1 over 1 over seconds, which is just seconds. So there's my final answer. Now, if you go back and look at the problem, it said a student is skateboarding down the sidewalk and travels at a constant velocity of 2.5 meters per second. How long will it take him to travel 1 kilometer? Do you see now that this question is actually super easy? It's just traveling 1,000 meters and going 2.5 meters every second. So of course it's going to be just 1,000 divided by 2.5. And the reason why I use this example is because students can often do a problem like this in their head, but then they don't know how to bring in the equations and they get all confused. And it's mostly because they don't know how to translate the problem to this whole host of givens, especially that the initial and final velocity are going to be the same and that the acceleration is going to be equal to 0. So don't be fooled. You can even do simple problems like this using the kinematic equations.